labeling the values, we have 0, and then this is 4 years from the initial value. This would be 8 years from the initial value. That's 20 years from the initial year. So when you're labeling those, just be careful. Can anybody give me an equation that they have? So it says, what's the equation of least squares? There are many different words that we can use for that. That's the same thing as the best fit line or the line of regression. So if you're not sure what that's asking for, there are multiple words or sets of words that we can use to describe the same thing. So when you use your calculator and you get that y equals equation, that equation is linear regression, the line of regression, the best fit line, the least squares line. So can anybody give me an equation that you got for that first part? Julia, what'd you get?
Y equals negative 0.02 x plus 12.02.
Nice job. So this one didn't ask or specify, but you will be asked to use 2 decimal places. So make sure you're using 2 decimal places. That just means 2 numbers after the decimal. So negative 0.02 and then plus 12.02. So the correlation coefficient. Emma, what did you get for the correlation coefficient?
0.86.
Yeah, 0.86. What does that tell you about the graph? Do you remember? Yeah, the closer that number is the 1, the more linear our data will look. So 0.86, I mean, it's getting close to like that 0.90 range. So this is probably a pretty close line, or the data would be fairly close to being a straight line. Since it's positive, it also tells us that our information is increasing. It's a positive correlation. But part C says, is the data linear or nonlinear? It doesn't form a perfectly straight line, so it's nonlinear. Unless this R value is 1, then it would be nonlinear.
The R value is negative.
Up, negative? Thanks. She probably said that. I just missed it. So if set to negative, it tells us it goes down instead of going up. Thank you, Connor. And then the next couple of questions are the interpreting questions. So what is the slope? What does it mean? What is the y-intercept? What does it mean? So in this case, what is the slope? Maggie, what's the slope of this line?
Negative 0.2.
Can you explain what that means?
Is it every 4 years that the other time is
And it's actually not every 4 years, it's still every year, even though the Olympics aren't every 4 years, because if I made this into a fraction, I would still just put it over 1. So we wouldn't put it over 4, because if you put it over 4, then you're changing the quantity. So it still is every year, even though you're counting by 4 years. So every year, the winning time you could say goes down, decreases, and then 0.02 seconds. So if we were counting by like 5 years or 10 years, you would still say every year. So once you calculate that slope, it's over 1, because really there's nothing on the denominator. So to keep it equivalent, we would just put it over 1. So we're talking about time, talking about the speed of the race, and the fact that that race, the speed, the time of the winning race is decreasing. So next question we have here, what's the y-intercept of this line? So Julian, what's the y-intercept of the line?
12.02.
And what's that tell us? What's that mean?
In 1928, that was
Yeah. Okay, so here's where I know yesterday a lot of people were a little confused. Because 12.02 does not match with the actual winning time. Because the actual winning time in 1928 was 12.2, not 12.02. And that's okay. Because our line has a y-intercept that crosses at 12.02. That's the line that fits most of the data. No, it's not going to meet exactly every data point. So the y-intercept is not the 28, 12.2, because that just happens to be where a point is. But the line that we're creating has a y-intercept of 12.02. So don't get that confused. Like, this is the line that we came up with, the average line that fits most of the points. All right, so the next question, what's the y or the x-intercept? So Mackenzie Myers, how do you find an x-intercept?
You make y equals 0.
So in the equation, we make y equals 0. Take the 12.02 to the other side. And then when you divide by negative 0.02, what do you get?
I got 601.
600 and, what'd you say? 601? Maybe I get something different? Alright, so what does that mean?
I said in the year 2529, the winning time is 0 seconds.
So in 2529, the winning time is 0 seconds. Now, of course, none of us will be around to see if that actually occurs, and if that does, wow, that's pretty amazing. They might have magical things happening in 2529. You never know. Questions? So that information there is going to seem off. It's not going to make sense. Letter G says, estimate the winning time in 1988 using your calculator. This one's tricky. So go back to the beginning. If we started in 1928, and now we're talking about 1988, Gavin, how much time has passed between 1928 and 1988? 60 years. So if we're calculating the winning time or estimating the winning time, we're talking about 60 years. That's the x value. Please show work. If you have an answer is not acceptable. I need to see how you got that answer. And it doesn't come from the chart. It comes from using the equation. So we're using the equation to estimate the time. So I need to at least see that you're plugging something in to the equation to come up with a matching time for the year 1988. Gavin, do you have a time for 1988? 10.82? So, in 1988, there was an Olympic athlete. Her name was Florence Griffith Joyner. She was a pretty famous athlete. She won the gold time of 10.54 seconds. It says, make a conjecture about this piece of data based off of the estimation we just had for letter G. So what could you say about her winning time? Julian?
She was slightly faster than average.
Yeah, she was faster than average, and she was pretty darn fast. I know you guys were nowhere even near surviving or living at that point. I was 8. But she was huge in the United States. Like, it was a really big deal for one of our runners to have this amazing time of 10.54 seconds to win the Olympics. I remember it, and I was only 8. It was like that kind of special thing. Any questions? Just like September 11th, I know exactly where I was. I was a senior in college. I woke up, I turned the TV on, and it was like, what the heck is happening? It's one of those things that you'll remember for the rest of your life because it had that much of an impact on history. So this was a different kind of impact, positive impact for the United States, but some things you just kind of remember. There's a lot of things I forget, but there's some things that I remember. Forget what my girls tell me. And the next day, like, Mom, I told you to put my library books in my book bag. I'm like, no, that's your job. Not my job. Even though I may have forgotten, if they did ask me. All right, so I was looking at the homework, and the homework looked really good. Just a couple of things. Let's see. Make sure that, like, if you look at number 11 from the first page with the broccoli, like, the homework looked really good as I was walking around. So in number 11, it asks you to decide what year the per capita consumption of broccoli would be 8.3 pounds. And you get an X value of 20.70. Please don't round up. Because if you round up, that's taking you to the next year. So the year would be 2000. And it's somewhere in the year 2000. We're 70/10 of the way through the year 2000. So, or I'm sorry, 7/10 of the way through the year 2000. So we might be talking about like September, but it's still in that year. It's not in the next year. So I know you're generally thinking, oh, just round up, because you're talking about years, but we can actually be in the middle of a year. So that number here, 20.70, please do not round up. So if we start in 1980, which was the starting point, and you add that, that takes you to 20,000.70. So don't round up to the next whole year, keep it in that current year. Because we do have months, 12 months throughout the year, so it's in one of those 12 months throughout the year. I think that was the only thing that I really noticed as I was walking around. Again, please make sure you're showing work for those last two problems, so just have an answer. Other questions that you have about the homework? No? So I have an activity that we are going to do. And Connor, I'm going to be putting you. You're in the front, you have to be close. Can you just place like 4 rollers, 5 rollers, and everybody's in the front, pass them back. We're going to see if we can determine if there is a correlation, which is another way of saying, is there a relationship between your shoe size and the length of your forearm? Because, I mean, you might as well just pick 2 random things and say, hey, is there some kind of relationship dealing with your shoe size and the length of your forearm? So Connor is getting a ruler for you. You obviously know your shoe size. We're going to measure the length of your forearm. Thanks, Connor. All right, so you can be student number 1. So you're going to write your shoe size down for student number 1. And then when you measure your forearm, like go from the inside, so from your wrist to the crease where your elbow bends, that would be the length of your forearm. So like, look at your wrist, measure from that wrist to the crease where your elbow bends. So you can put that information for student 1. So you can be student 1. So write your shoe size down and then the length in inches of your forearm. Did anybody not? I think they're all inches. Anybody not get a roller that's measured with inches? So you're going to ask then 9 other students what their shoe size and length of the forearm is. It's okay for you to ask a male if you're a female, and it's okay for you to ask a female if you're a male. It's a 1.5 conversion. So if a male has a shoe size of 8, that means as a female, that male would wear a 9.5. So, like, if my brother had a shoe size of 8, if he wanted to get a female pair of shoes, he would wear a 9.5, and vice versa. So if I have a 9.5, which my feet are tiny, they're not at 9.5, then I would wear a male shoe size of 8. So just kind of know that conversion. So if you're a male and you're asking for a female size, you need to subtract 1.5 because your numbers need to be all in males if you're a male. If you're a female, you need to add 1.5 if you ask a male, because your values need to be in the female size. So make sure you're looking at that conversion when you're asking the students in your class. So again, you got to ask 9 other students, and then there's a couple of questions underneath there for you to look at. Whenever you're done with this, I will be collecting it. If you're not done today, then you can finish it up for homework, and then I do have a review worksheet for your quiz tomorrow, so you can kind of collect that as well. So get up, walk around. I'll put my information on the board.